Okay, we can start.
Okay, sir. So, good afternoon, everyone, and a very warm welcome to all of you to our first event of this year. Parigyan is the Data Science Society of GIM with a focused vision to create data science evangelists who would propagate knowledge and insights of data science among the student community as well as outside. We believe in spreading knowledge and bridging the gap between business and data science. Now, with immense pleasure and excitement, I would like to introduce you to our speaker for today, Mr. Shelendra Kumar, Vice President and Chief Evangelist at SAP Sydney. He's a keynote speaker and a thought leader in artificial intelligence space. Published multiple articles about advanced analytics, machine learning, IoT, and blockchain, and recently published an Amazon bestseller, Making Money Out of Data, which showcases 5 business stories from various industries on how successful companies make millions of dollars in incremental value using analytics. It is our pleasure to extend a warm welcome to you, sir, to enlighten us with the power of analytics revolving around your work on making money out of data. So you can introduce yourself and then we can start with the presentation now.
Good.
Meanwhile, the students, please keep yourself on mute and you can ping in the questions that you have in the chat window.
Okay, let me share my screen.
Yes, sir.
Okay. So, guys, first of all, thank you very much for taking time today to hear me. I was there last year. I think. Can you hear me, guys? Everyone can hear me?
Yes, sir.
Perfect. So I was there last year. I think it was on 11th and 12th of November at your college, and I did one of the presentations at the time, and I had to leave very quickly at that time. But having said that, I thought I would reach out to you guys and have another discussion to share my thoughts around what analytics and what data science can do to the industry. I would like to keep this a very interactive session. What I will do is I will do a bit of presentation and then I will open the forum and I would ask you to open your cameras and your microphone and ask questions to me, and I'm more than happy to take as many questions as possible. So very quickly, I'm sharing my screen at the moment. Are you able to see my screen?
Yes, sir, we can see you.
Okay. So, making money out of data. This is the name of my book as well. Let's start with talking about the book itself. The book is a journey of mine for last 25, 26 years, where I have been involved in various analytics projects. I call them analytics projects because long time ago, people, in the past few years actually, people have changed names from what we call analytics to calling it data science, to some people even call it artificial intelligence. So there is a bit of jargon thrown out there. I like to call it analytics itself because it is analytics. So it is, the book is a story about, it's a story containing 5 different projects, 5 different industries, which include financial services, banking, which is financial services, banking, telecommunications, retail, and CPG. So that's what the book is about. But what I've done over the years, and some of the people, when you talk to them and you ask them what is analytics, they would call analytics as reporting. Whereas I am one of the persons who said reporting is an IT function, whereas analytics is a business function. And the idea behind analytics is to solve problems and to understand what kind of business issues can be solved using data. So you use not only collecting the data together, but also you will be involved in making sense out of that data, and that's what analytics for me is all about. And what we will do is today we will try to peel that onion as well as we go into the discussion. And I would love to hear your thoughts as well, guys. What do you think about analytics? So let's have that interaction after the session. I'll try and keep the slides very short, and then go from there. So if you look at the next slide, what I've tried to do is highlight or put forward key questions that you could solve or you could answer using analytics. And sorry, you can see me. Yep, perfect. What analytics provides you is the ability to answer questions, and that's what people try to do, and answer questions which are important to the business. So things like, if you're a retailer, you would like to know price elasticity of demand in advance. So you want to know what product would be sold at what price, which is the best price, optimal price, as I call them, so that you can get more and more customers into the store. Or if you've got a website, then what is the optimal price for that website for that particular product to have, so that you've got enough people coming into the store. Similarly, if you're a marketing function in an organization, then if you spend $1, it is said in marketing, if you spend $1 on marketing, 50 cent is a waste. So if you were to find out where that the remaining 50 cent can go, so that which is a waste can go and utilize judiciously, then that would be very, very interesting, because if you know that this 50 cent is going to be a waste, then you're not going to throw them, right? So you're going to put them into the right place. Similarly, if you were talking about a network of a telecom company, then when they're putting out network, they're changing the network. If they understood where my core customers are, then, for example, if they're upgrading their network, then they would know that where are my most important customers, and where do I make that change first, and where do I change that going forward, and so forth. So, and if you're running a kind of a operational process, then you want to know which part of the process is likely to fail, and if it is going to fail, what is the impact on the entire end-to-end process, and how you are able to find that out. So these are the kind of things that analytics help you solve questions, and it's not important to understand what has happened. It's important to understand why has that happened, and why is it going to happen in the future. Because if you know why is it going to happen, why is it happening, and it is going to happen, then you can do something about it. I usually call myself, if most all of you are from India, and you must have seen a guy sitting on a corner of a road, looking at your hand and trying to predict your future, and saying, well, so imagine I go to someone and show my hand, and he says, you're going to die tomorrow. Now there are two things I can do then. If I find out that I'm going to die tomorrow, then I will try to avoid that. I'll try to save myself. I'll not get out of the house or whatever. I'll try to protect myself. And in doing so, I will do one of the two things will happen tomorrow. Either I will die or I will not die. If I've done enough work to save myself, then I will go to the guy and tell him that your prediction was wrong. But if I died, then what was the point of the prediction? So I'm actually stuck in that situation where even if I'm right, I'm a loser. Even if I'm wrong, well, I'm a loser anyways then. So this is the kind of construct, and this is the kind of thinking that you need to bring in, and when you're doing analytics, you need to think all of that about. Okay, very good. So analytics basically is not new, and it's just changed names over the years. So if I look at what has happened in the past, analytics, or it all started in 70s when computers actually came into play. So we started with some kind of batch reporting, and then there were paper printouts where the CEO or the CIO would look at all those pictures and try to map those numbers and on paper. And that led to ad hoc querying, and in 80s and 90s, as I remember, 90s actually, data warehousing was huge. Everyone wanted to build a data warehouse where all the data coming from all the different parts of the business into one place, and people would be able to look at the data and cross tabulate, and what we had at the time was online analytical processing, which is OLAP. which allowed you to actually drill down, slice and dice data and so forth, which led to, in early 2000s, dashboards and visualizations and all of that coming into play. And in later 2000s, which is around about 2010s, alerting and predictive analytics became huge. So people started talking about alerting. What they said was, if I'm finding something, then I should be alerted, and I should be able to predict what's going to happen. So it's a journey that analytics has gone through, and now we're getting into a situation where we're trying to do event automation, cognitive, where you're not even understanding what's going to happen, but we're also telling the customer or telling the individual why is it that going to happen and what is the impact of that on your business, so that you can make that change as you go forward. So things have actually changed from where they were to where they are, and it is going to change as we go forward when we talk about cognitive, and the machines are going to work by themselves and run their own business as they go. I'm sure you guys are able to hear me and there is no interruption. I'm not talking to a wall. You guys can hear me?
So we are able to.
Okay,
Yes,
perfect.
sir.
Perfect. So that is what has happened. So now if you look at analytics, one more thing that came to mind, or one thing other than analytics that actually triggered me off, was the fact that anyone and everyone was saying that they're doing analytics. So anyone who was even collecting data was calling themselves doing analytics. Someone who was reading an Excel spreadsheet used to call themselves doing analytics. So I thought, let's look at this into a different perspective. So everyone is doing analytics, but there are various layers of sophistication. So you've got managing information, where you're bringing in data together, where you're getting data from different sources, whether it is a customer data, whether it is a sales data, whether it is marketing data, product data, social media data. You're bringing in all together into one platform. So these guys are basically doing data integration and bringing all that data together. So this is the fundamental layer of data analytics, or analytics in per se, where you're bringing in data from various sources into one place. Now the next layer to that is descriptive analytics. Now when I say descriptive analytics, what we're saying is we are creating some reports which can be sliced and diced, and which can go into so you can understand what's happening in the business, and every week, every month, there is some formula that is running at the back on your system, and it's presenting a result to you and presenting a report to you at the end of the day. So this is where descriptive analytics plays a very important role in the entire business area. Now, what kind of things you do here? You do reporting, you do dashboards, you do visualizations, you do segmentations, customer segmentation, product segmentation, social media analytics. What you're trying to do is, you've got some kind of analysis or some kind of pre-baked formula that is written and that is going to run every time. So there is no, well, I would call there's no intelligence in it, but it is a formula that is going to run end to end. Now, when that report comes to someone, they would find something and they would have questions in their mind. Now, for those questions, they've got in the business what is called ad hoc analytic services. Now, these services, their job is to answer questions. What happens is they'll pick up the phone and ask their people, what if, for example, sales in Goa are down, but sales in Mumbai are high, or sales in Mumbai are low and sales in Goa are high. So what if I drop the price of that product in Goa? Will that increase the size, the sales in Goa or not? So these are the kind of ad hoc questions that you will have, and you have to answer those questions. So there are organizations which have got these analysts sitting in the organization who answer these ad hoc questions as you go. The fourth level is the predictive analytics level, where people want to understand what is going to happen, why is it going to happen, what are the various reasons behind that to happen, which are the three most important things for you to predict. If you take that example of the guy sitting on the road trying to predict your future, this is that guy who's always in trouble, because he's going to predict and help you with defining actions that you are going to take to avoid a particular situation, or even be ready for that particular situation to happen. For example, we couldn't predict COVID. If we were able to predict COVID, there would have been some kind of work that would have been done in the past. We couldn't predict COVID because nothing like that had happened in the past. Similarly, people don't know if a new mobile phone is being launched, what will happen to the sales of a telecom company. They don't know because they have not seen that in the past. So some things you can't predict because they just come hit you, but some things you can predict. Now they can predict what will happen if a new mobile phone comes in because they've seen that 4 or 5 times, or for the past 10 years, they're seeing that when a new mobile phone, a new Apple phone comes in, or a new Samsung phone comes in, the sales of the telecom services sales go through the roof. So these are the things that you can use and create predictions about your business and predictions about what is going to happen. So this is very, very important slide where their level of sophistication. Now, if I turned around and asked one question to any one of you, and even to the folks who are in the business world, they would definitely tell me that you have to build this through starting with managing information, then building some reports, then doing some ad hoc services, and then building predictive analytics. It has to be a one from. Let me just show you. So let's look at that. It would be. Sorry. If I can do this. Yep. So this is 1, this is 2, this is 3, and this is 4. So what they will tell you is that you got to get the basic data structures right, data in one place, and then you will go build some reports, then you would answer some questions, and then that's where you're going to do some predictive analytics. I also come from a school of thought and say, I'm sorry, you can actually do another way, and that is 1, 2, 3, and 4, which means that you start with predictive analytics, you define some business problems, try and solve them, and collect data to do that, and suddenly you will start collecting data and solving some business problems, and at the core of that, start collecting data. So you don't have to start collecting data without any solutions. You actually solve a problem, collect data for that, and you start solving second problem, solve third problem, and in the process you're collecting data. So you don't have to wait, because if you did the other way around, other than this, then you will have to actually wait for 5 or 6 months or even 1 year before you get the data there to build something. In this case, this is an agile solution where you can get things done in absolutely no time, and you can start getting some results very, very quickly. So yeah, that is an important aspect of looking at how you look at the 4 tiers of analytics. Okay, now for you guys who are trying to go into the business world, what is going to happen is, I'll just get this out. Okay, what I see in the market is that in early 2000s, a lot of time was spent in reporting, data collection, analysis, and insights was little, and advanced analytics or predictive analytics was absolutely really, really very little. But what's happening today, and this is a moving slide, what's happening today is that organizations are spending more time on advanced analytics and analysis, and reporting and data collection is becoming automated as they go. So they don't want to spend too much of time on reporting and data collection, but they want to spend too much of time on finding solutions, on understanding what's happening with the data. So data virtualization and issue-driven insights and measures are becoming key. Business intelligence, once a report is being built or once an analysis is being built, it actually takes them to the next level. So this has changed. What I'm assuming is that going forward, this is going to change even further, and we will have more people working on the predictive analytics side of things or advanced analytics side of things, and less people working on reporting, because all of that reporting and data collection can be automated as we're doing it today with Python and R and all those softwares which are allowing you to do all that data collection and automating them. So the world is moved if you look at it. So if you guys are looking to get into market, most of the time, and there is dearth of people who are actually doing advanced analytics, which we also call data scientists, and we will have a chat about that as we go forward. But this is how the world is moving, and as we go forward, the demand will get onto the analytics, advanced analytics and analysis side, and less demand on the reporting and data collection side will happen. Okay, Now, advanced analytics is also, or data science is also at the heart of artificial intelligence. And I don't know how many of you actually understand the difference between artificial intelligence and data science and machine learning and not. We will talk about that as we go. But look at this slide and try and understand that you've got huge volume of data and you want to learn from that data. You want to actually first of all ingest information as it comes, whether it is coming in a text format, whether it is coming in a visual format, whether it is coming in a voice format. So for example, I could pick up my Google phone or Samsung phone and say, hey Google, and it will start, and it's actually responded, and you can talk to the phone. When you're talking to the phone, what it is doing is it's converting that voice into text, and it is converting into text and also making sense out of it and predicting what kind of answer that needs to be given. And that's where advanced analytics or machine learning actually plays a very, very important role, because it is predicting what is the best answer for that question that has been asked. So you start from collecting data and you end up probably solving a problem or giving a solution. For example, if you wanted to know a very simple question that we ask all the time, what will be the weather tomorrow? Now, what has happened is, first of all, my voice has been translated into text, and once that's gone into text, someone has interpreted it, the machine has interpreted it, and actually found out what will be the weather tomorrow, and has come back to respond back in voice itself to tell me what the weather will be tomorrow. So basically, it's an end-to-end process, and that process is artificial intelligence. Now, it has got various components of it. There is data collection in it, there is analytics, there's statistical modeling in it, there is then reaching out with that insight back to you as well. So it's got all those components working together at the same time. And as we're going forward, what we are also seeing is that deep learning and deep neural networks, which is neural networks, well, people will say deep learning is neural networks and it's just come in. Actually not. We used to do neural networks 20 years ago. Neural networks has been there for a long time, but now it has got a particular mission to solve certain problems, so it is being taken much more interestingly. But computer vision, natural language processing, and generative models, this is all coming into play as we go forward, and then it pushes back using natural language processing or visuals or videos or text, whatever. So deep fakes is another thing that you could do using artificial intelligence, where what you're doing is you're telling the system that you want something in that format and the output is a video. So these are the kind of things that you would do, and artificial intelligence, the heart of artificial intelligence is advanced analytics, statistical modeling, or machine learning, if you look at that. I'll take questions on this, and I'm sure you'll have a lot of questions on that. Okay. If you bring all of that together, there are huge benefits, and I'll take two examples. I usually talk about these two examples, which are my own personal examples which we've delivered. So if you look at this, a large retailer in the US wanted to profile an employee, so who is likely to leave. So what they were seeing was, they were seeing a lot of attrition within the first 6 months to 8, in less than a year. They would see 6 to 8 months, 6 to 8 to 1 year, they would see a lot of people leaving. So they wanted to understand what is the profile of the employee that is likely to leave the organization in less than a year. So what we did was, we brought the data from social media, we looked at the internal employee data, their performance data, and built a predictive model. We scored each and every customer, each and every employee, and gave them an attrition score. Now, that is very good, but that's not actionable. I know that, that particular person is going to leave us. But that is only once this has happened. So I wanted to understand, what is the profile? What are these kind of people? So when I'm doing interviews in the first place, I would resist hiring these kind of people. So we created a profile and gave the characteristics of people who are going to leave the organization in a year's time. So what they would have to ask certain questions to the employees, or prospective employees at the interview level, so that they don't hire people who are likely to leave, by understanding what they're doing and what their lifestyle is and what kind of things they do. That significantly reduced churn or attrition for them, and they were able to actually save around about $12 million in the end. So it was a huge exercise. Now let's look at IT operations. Now this is a CPG which has got a lot of KPIs. So I remember I asked them a question: how many reports do you have? So they said they just spent a few $5 or $6 million to build 555 or some that odd number, which they had that many reports. So the question was, I asked them, so how many people use those reports? So the answer was that people only used 5 or 6 reports. Rest of the reports were not being used. So what we did was we then got all the information to understand what people actually wanted, what people wanted to see. So we created early warning system where we said, okay, fine, if this is going to happen, you will get an alert. But these are the certain KPIs that are important to you, which you should look at on daily basis or weekly basis or monthly basis, whichever way. But if anything goes wrong in the business, you will get an alert, and that will solve a lot of problem for you to keep looking on reports. Instead of that, you will not be looking at reports, but you will be looking at you will be looking at solving the problems that the business has and running the business, not looking at reports. You don't need 550 reports to run a business, no matter how big the business is. So that's where we helped the organization, and the organization really created those 5 or 6 dashboards or reports, you call them, and rest was all alerts, because there are things that would only change in once in 6 months or maybe not. Why do I need to look at them? Why do I need to chase them all the time? So these are the two different use cases which were really helpful and saved a lot of money for these organizations. So these are the kind of, so what I'm trying to help you with is to understand what kind of projects that you guys see, and when you go to market and when you go to the business, to understand what's happening. Okay, now if you look at organizations, various type of organizations, various industry sectors, you would see that these organizations have a lot of analytics based projects. Now what are these kind of projects? So for example, government looks at fraud detection, crime prevention, revenue optimization for a particular part of the government. Apart from that, they do a user experience or a citizen experience. When a citizen goes to meet the government, what kind of experience they have. On that part, government could actually use data to actually control COVID. That is one of the things which I've just mentioned, that there is a solution to that as well, and we can talk about this if you've got other ideas. Financial services do a lot of credit scoring, fraud detection, pricing, claims analysis, underwriting. Retail organizations do promotion replenishment, price optimization, merchandising, supply chain optimization, all those things. Hospitality does customer loyalty and pricing. So if you go to an organization, go to a hotel, then you get to understand the customer loyalty aspect of it. Trading, supply chain, and all that stuff is happening if you look at that in the energy sector. And every business looks at performance management, and this is a huge list and exhaustive list, but there are quite a few things that you would see when you go and meet people in these kind of industries, and that will be very helpful for you. Okay, now important characteristics of a successful analytics environment. So what is important for an analytics environment? A very important aspect is visuals. It is very important because communication is very important. You need to explain to the business what it means, and so that could be very easily explained through visuals than numbers. And so visuals are very powerful, and they have to be very beautiful. So I usually say you need to have a very beautiful environment to actually showcase to the business. Predictive. That environment should be able to predict what's going to happen. And then collaboration is important, because if you find something, or if you've predicted something in the data, then you should be able to collaborate with the business so that they feel part of the business and they feel that they're part of the whole process and they take action on it. And it needs to be integrated with all the other environments, because the data is lying at so many places, it needs to come together. And it needs to be live and connected. We live in a connected world. I usually say a day is a too long a time in today's world. So it needs to be live, it needs to be connected, and it has to have a storytelling. If you can't tell it through a story, I doubt anyone will buy anything that you've done in analysis. And it is very important to narrate a story in a format. And I ask this question when you sit down to all the students, when you sit down in your lunchtime, what do you talk about? You talk about your own personal stories. You don't talk about numbers. You don't talk about how much did you get in that particular subject, or but you talk about stories, you talk about what's happening at home, you talk about what's happening with your friends. So storytelling is very important and has to be real time, because as I said, times are changing, and when times are changing, the whole thing is actually get up in 1 year, 1 day is a too long a time if you look at it. Okay. When you embed analytics in processes and you make it industrialized, this is what you require. So there are two aspects of it. One is craft, where it's one-off, ad hoc, or it is industrialized, where it is running one in a go and it is all part of the business. So if you look at the differences, the pattern, you look at it, it is ad hoc, craft is ad hoc and project oriented. It is embedded, whereas the industrialized is embedded into processes. So all your processes will have some kind of analytics embedded into it. Purpose, one-time decision or event support. So what happens with the craft one is it's like one-time exercise. Whereas industrial, it is an ongoing process performance. It's a circle. It starts from collecting data and it keeps on going, and it is that's where it goes to. From benefit aspect, when you do a craft understanding, it is one time, whereas industrialized, it is recurring, and you keep on doing it again and again. From investment perspective, if you do one-off, it is going to be expensive, whereas it is lower and one-time exercise. It may be because when it is industrialized, it just keeps on going as you go. And for staff, one-off is quite labor intensive because you got to build it and you got to share it with the business, whereas in industrialization, it is all informed and automated and part of it. Speed wise also, the time to implement a craft environment is quite, though it is same time to implement one-off, every time you do that, you will spend the same time, whereas once, if you build it for the first time and industrialize it, then it is fast, and thereafter it is just run of the mill and keeps on running. These are the key important differentiations, and most of the organizations today are in the craft area. At least in India, you find them in the craft area, but they're moving towards industrialization because they've understood the importance of making it industrial. Okay. Now, there are challenges in execution of analytics insights as well, because these are the kind of questions we see in the business most of the time. So if you're an analytics person and you go and talk to the business, they would say, your analytics model doesn't make sense and I don't think it'll work. They won't have that confidence, they don't have that trust on that predictive model that you've built or statistical model that you've built. They will also say things like, I know more about my business than your analytics can tell me. From team wise, I'm told to align the data, but I don't know why. Whereas the team is saying, I'm doing something, but I don't know why am I doing that. And that's where it is. And finally, when all of that happens and no action is taken, it turns around and says analytics is just yet in the jargon and does nothing. And that is where the whole thing falls apart. And that's where what we're trying to do is trying to avoid that whole thinking. So it is important for you to involve business right from day one. Make sure that they take this as part of their business, and they think that it is about their part of the world that they're doing it, and it's not something which is gobbledygook and they're not going to execute it because it's not what they were doing with it. So that is one of the key aspect of execution, and these are things that when you go into market, when you go into industry, you will find the same kind of issues with the business, but then that's where you need to help them. So you need to be involving business as you go, right from day one. From team perspective, the guy who's actually playing with the data would have much more knowledge about the insights within the data because he's playing with the data, and he should be able to engage with the business and with the statistical models as well to tell them what he's found in the data. So it's important to work as a team, and team building is an important aspect of it. Okay. Usually people say start from the end. People say, or if you remember Shah Rukh Khan's, what was that? Kuch Kuch Hota, and he said start from the start, which is what Microsoft also says, start from the start. I say start from the end. Start from the objective that you're trying to achieve. Start from what are you trying to do. Not start with, give me some data and I'll do something about it. Define the problem first. Identify the opportunity, quantify the value that it will bring, and define the outcome and the execution. And define what kind of outcome that you're going to get and whether it will be executed or not. And what will be the value to execute that particular model. And to do all of that, you would need to do design thinking, bring your business together with you and take it from there. And that is very important. When you go to the market and you start working, you need to start thinking from the end result. What is the end result that I'm going to deliver? What is the opportunity that the business is going to get? What is the objective that they're going to get? What will be the value? And if you can't define the value, don't bother doing it. And that's very, very important. I think that's all I have. And let's get on to the question and answers. If we've got here, where are we, guys?
Yes, sir.
Okay. So let's go ask questions. What's going on?
So we have one question from Meghna.
Okay,
Meghna, are you there on the call?
only one question. Okay, let's start.
Your question.
Sir, I wanted to know that how can analytics be used in field of equity research? Like, just if you could give us an example.
Equity research. So when you say equity research, you mean we're already so we've hit the half an hour. Okay, when you're talking equity research, you're talking about stock market.
Yeah. For
Okay.
example, if I want to buy a share, so how can I analyze which company should I go for? Like, that's what specifically I want to know.
Very good. So you want to be rich. You want to be rich very soon. Good stuff. Actually, I did a project on this, and I'll tell you what it was. So do you know that on Yahoo Finance, each and every stock, since its existence, daily data is available on Yahoo, free. Okay,
Yeah, sir.
you know that? Good stuff. So that data that is available for free, you can download it and build a model to understand which all products are going to go up or down at any given point in time. I did a project on that. So what I did was I figured out all the components of all the shares that were there, which I could figure out, and I pulled them together into a modeling technique, and I used a RIMA model to find out which share will impact, or what it was to identify which stock will go up and what will be the impact of that particular stock on the other stock. So that way is what will happen is if stock A goes up, which means, does that mean that stock B goes up too, or does it go down? When you're trying to build that, and when you start doing that, you will build it with a few stocks and will only use the share market data. But then suddenly you will start exposing it to other kinds of data, which is like weather data, because there is weather impacting shares as well. Then you will use your social media information to understand what's happening about that share. If you try and get all of that information in one place, you can very, very well predict the price of each and every stock for tomorrow, day after tomorrow, as and when you want. But it needs a bit of iteration on that. and you can use, I'll give you a trick there. You could use ARIMA model because it's a time series, and you could build an ARIMA model to actually get that done.
Yes, sir. Because like what I analyzed was that in stock market there are X number of factors that affect the stock, like economy and all that stuff. So there are lot number of variables which we need to consider to build a model. So that's what my point was.
Yep. So you need to actually look at all the kind of models, all the kind of analysis that is coming, and take it from there. And I'm telling you, this is a huge exercise. It will take a lot of time for you to build, but once you get it right, I am 100% sure it's going to, you'll be a very rich person.
Thank you, sir.
Thank you, sir. So we have another question from Satyaki. Are you there on the call?
Yes.
Yes, you can go ahead with your question.
Guys, if you can switch on your camera as well, I want to see your faces as well. What's going on? Why are you hiding?
Actually, sir, there is some network problem in my area, so actually that's
Okay.
why I'm not
Okay.
able to switch off my camera.
No
So
worries.
first of all, thank you for this wonderful presentation. So actually, I have a question that you actually mentioned that advanced analytics part, right? So actually, I want to know that what comes under advanced analytics, and what is it basically?
Okay.
Advanced analytics and the difference between advanced analytics and analytics.
Okay, so as I said, and if you looked at the slide which I showed around different kinds of analytics, which was descriptive, uh, sorry, data integration, descriptive, ad hoc, and then predictive, right? So advanced analytics is a term that is used alongside either predictive analytics or predictive and prescriptive analytics together, is what is advanced analytics.
Okay, sir.
Any other questions?
Yes, sir. We have another question from Harsh.
Hi, Harsh.
Harsh, are you there?
Hello. Hi, Harsh.
Okay, so I'll just read out his question. He's asking that how could analytics help in credit limit estimation of SMEs?
Okay, that's a good point. Credit limit of SMEs. You can actually see, all of these are projects by themselves. I can't, we just can't talk about, because every SME is different and every SME needs to be taken as a different environment. But what you can do is, you can, when you're doing a credit limit for each and every SME, you can club them or categorize them, or segment them into various kinds of SMEs. Use the data that is available for that SME in terms of how much they've spent, how much what their value is, what's their revenue model, and all that stuff. So there are lots of data sources that you need to extract from there, and I think the best answer to do that is actually, before even doing a credit score, you need to actually segment them and group them for that particular business or for that particular bank which is trying to give to do that credit scoring. Now, most of the credit score, most of the organizations actually have, in most of the countries, have an organization that defines credit score for that particular organization. It is for all the SMEs in that particular country. That has been done. So, for example, in Australia, we've got Bureau of Credit, which actually provides credit to all the SMEs. Similarly, in India also, the credit score is already provided by a large organization. But if the bank wants to do that individually, they can do that, but they will need all that information about the past information about that particular SME. Does that answer the question?
Yes, sir. Thank you. So we have another question from Ishan. Ishan, are you there on the call?
Yeah, can I go?
You can ask.
Hi, Ishan.
Hello. Uh, as you know, so there is a huge debate going on right now about privacy regarding the data we are collecting. So I just wanted to know what are your thoughts or insights about it.
Good stuff. My personal view, privacy is a myth. It doesn't happen. When you leave your house, there is a CCTV that's capturing your face, and the technology is such today that I can identify you with your face. Well, of course, there is facial recognition going on. So, if you're very worried about privacy, then you should wear a burqa and leave your house. Otherwise, there's no privacy. Where is it? Did you get my answer?
Yes, sir. Thanks.
What are your thoughts on this?
Uh, I think there might be a way to balance privacy and data collection, but I'm not sure. So obviously, I'm kind of new to this field.
Okay.
Thank
Okay.
you, sir.
Yep.
Thank you, sir. So we have another question from Shalini Singh.
Hi,
Shalini, you
Shalini.
can go ahead with the question.
Yeah. Hi, sir. So I wanted to ask about the GPT-3 model. Like it is already pre-trained and like it can solve a lot of problems without training it again. So what would be like the future of NLP models that would be built here on, like the changes that would bring to the building of models?
See, I'm not an expert in NLP, and what I would say is that with all the modeling and all the models that are being built and trained as we go forward, they're becoming smarter by the day. And with all that breaking in the data, I think it is becoming more and more intelligent as we go forward. So, in my view, NLP is the voice is the next big thing. In fact, I just ran a show last week. Yeah, it was last week, where we were talking about voice assistants, and voice assistants actually, as you know, uses the entire NLP construct in it, and use the GMP model there, and try and solve for converting that voice into text and then utilizing that and solving that problem. And I think it is getting better by the day. Yeah, there are certain issues that we are, but by the day we are actually increasing that thing. And in fact, I'll tell you one thing. Going forward, what is going to happen is that even you won't even have to write SQL. You will be able to ask the question to your BI environment to say what were the sales yesterday, in as simple plain English, to get an answer. And in fact, SAP is also doing that with their entire SAP Analytics Cloud platform. An important aspect of NLP is the cloud environment, because if it is not in the cloud, you won't be able to match it with other sources of data to get a better answer. So that is also very, very important, and that's happening at the moment as well. And if all of that works in the cloud and we get good networking environment, um, I think we're there. It is making a huge difference.
So can you tell us more about the SAP Analytics Cloud? Like what are the products and how is it used?
Okay, SAP Analytics Cloud is an environment where you've got a capability to create stories. You can write your own stories with data, with graphs. It has got machine learning built into it. And when you look at machine learning, what it is doing is when you drop, so for example, you've got a data set, right? And you want to create a graph. You drop the graph, it will actually define which is the best graph to depict that particular data set, or that particular row or column, whatever you've used to put graph. So apart from that, it's got smart insights, which actually looks at the data behind it and provides you insights to that particular graph. So you just built a graph, but that's a dumb graph. It needs some kind of explanation to that. So that explanation is created, which is called smart insights, and there's machine learning running at the back, which figures out what is there, and all of that, because it is a cloud-based solution, all of that happens in real time. So you create a story. You're not only creating a story, you're also getting insights from within that story as well. And that is very, very interesting, because we are building each and every process of SSC has got machine learning built into it. Make sense?
Right. So how is it different? Is it the same as AWS Data Lake and AWS Cloud Services, or
No.
does it have some?
So you need to understand the difference between. So remember, I showed you this slide where you've got the data integration and the descriptive analytics layer. So this is something in the middle of descriptive and predictive. So what you're doing is you are creating a presentation layer which is working on SAP HANA, which is where all the data is being stored and is easily accessed. So we use S/4HANA for that, and then from there on you pull on what you want to show. Now your question was whether that is equal, that is like AWS. AWS is an infrastructure, is a hub. So let's look at your computer and let's look at that. Okay, and let me make it simple for you. You've got a computer, a CPU. That CPU is AWS platform in the cloud. So someone has put that, your laptop, someone has put that in the cloud. That is AWS, right?
Yeah, I got that.
And then the software on it, and there is database on it. So there are three different layers, and so these three different layers. So SAC or SAP Analytics Cloud is the presentation layer, which interacts very, very quickly with the data layer.
Right. So it interacts with Data Lake
Yeah.
and does not have like a Data Lake itself.
No, it interacts.
Okay.
You can use
Okay.
you can use S/4HANA because it is very quick, it gets very quick results. And then you want to run machine learning in it, which is running at the back, at the core, because you need grunt to run machine learning, you need grunt to run statistical model, right? So that is where it goes back and starts running it.
Okay. Thank you, sir.
Thank you. Any other questions, guys?
Thank you, sir. Yes, sir. We have another question from Tarun. Tarun, are you there on the call?
Tarun?
So I'll just read out his question then.
Yep.
So he's asking, how does someone who is new to analytics field build his foundation in this field with respect to industry so that he can put his best foot forward?
Good stuff. And I'm so glad that that question has been asked, and for all of you to understand that. And actually, I'm creating a video on this, and that video will be on my YouTube page very soon, which is actually catering to all the guys who are very, very interested in becoming data scientists, or are beginners or enthusiasts who want to do something something from in the data science point of view. But I'll give you a very quick 2 cents worth. But that video you must watch. It is on my YouTube channel. So all of you guys, as I said in my presentation as well, you need to focus on the question. And today, you guys are in India. There are lots of challenges in India. So you define a business problem, or a social problem, not a business problem, sorry, a social problem, and try and find the data for that. And look at what statistical modeling can actually help solving that social problem. For example, I threw that question on COVID-19. So when COVID-19 came in, I said, well, how can we use data to actually solve COVID-19? Or if we can't solve the problem, we can still control COVID-19. So what can we do? So it's a social problem. You define the social problem and then look for that data. And data is available today, everywhere. When you get the data, you then need to figure out what you need to do to actually solve that problem. Now again, today, and I'll tell you the difference between, why am I saying that also? When I started work 26 years ago, to get a license of, well, there was no R, there was no Python, there was nothing like this. You could only have SPSS or SAS. To get a license of SPSS or SAS, it was $250,000. So you and me couldn't afford it. Even today, I can't afford it. Even today, you can't afford it. It's not that cheap. But today, you can get Python for free. You can get R for free. So the software is free, hardware is free. You've got everyone has a laptop. We didn't even have laptops in those days. Laptops were so difficult to have. To get a laptop, you need to get a job. You don't need to get a job to get a laptop. You have a laptop. Well, if not, AWS has got what, $25 a month kind of a subscription model, or Azure has a subscription model where you can actually post all that data there. What you're collecting, you can put it in the cloud, from the cloud kind of thing, and you can, and all these things, all these Python and all these software training is absolutely free on YouTube. Just go type Python training and you will find hours of training. Now then comes the thought, I've got a problem which I'm trying to solve. I've figured out the data that is required to solve that problem, and that is very commonsensical. It has nothing to do with analytics. And now what kind of models will I apply? Everything is absolutely free, or cheap. In other words, not free, cheap. Inexpensive, I can say. You start practicing. And I say to people that people who are in the data science field will not need a job. You will be giving jobs to people, but you need to be driving your own sense. You will need to be working on what you're doing and utilizing your thinking to actually deliver something, deliver a kind of answer to a social cause, or any business cause also. Once you do that, what you find is that, you've trained yourself, you've figured out what you are bringing to the business, and when you go to look for a job, you will have experience to show, which no other industry gives you for free. Tell me which industry gives you a free training environment. Data science does. Does it answer the question?
Yes, sir, it does. Thank you, sir.
But but I would certainly say, if you guys follow me on Twitter, LinkedIn, and YouTube, you would be able to you would be able to find a lot of resources. And also, I time and again bring in leaders from different industries to actually come in. So I run two shows. One show is on every second Thursday, and one show is on every Tuesday, and they're live shows where I bring in leaders. So I get, for example, every Thursday I do women in data science, where all the women, or where the key leaders in data science, women leaders, they come on the show and they talk about their success stories, the successful projects that they've delivered. You could watch that as well, and you could learn a lot from them. We've run around about 11 shows. Then there is one which I call Artificial Intelligence Startup Series, where we get the CEOs of of startups who are actually focusing on AI, and we bring them in and they talk about what is their journey being, what are the kind of problems they're solving, and so forth. And that comes on every Tuesday, every second Tuesday. So the next one will be on, I think, 1st of September, and then there is one on 27th of August is the Women in Data Science. So you attend those sessions, you learn, there's free learning, free training all over the place, and you learn from them as well.
Yes, sir, we'll surely do that. Thank you. So we have one question, I think, from Harsha. Harsha, you had raised your hand. Do you have a question? Okay, I'll just go ahead with the next question that we have from Neeraj. Neeraj, are you there?
Yeah,
You
I
can
need
ask
it.
your question.
uh, good afternoon, sir. It was a very insightful session. Thanks for taking time for us.
Yep.
So my question is like, I'm having my prior experience is like analytics field only, like it was data warehousing project.
Mm-hmm.
So where I worked for quite some time.
Mm-hmm.
So I am having skills in like ETL as well as BI. But I was confused, like, what should I focus my career on further here onwards, like whether it should be marketing or whether it should be IT and operation. But finally, I decided to go for IT and operations. So, what would be your suggestions? Like being a pioneer in the market, you obviously have seen a lot of industry people, and you know what they're actually looking for in the candidate like us, right? So, what would be your recommendation from that point of view?
See, I usually say you should know your know your skill. That is very, very important, right? It doesn't matter for an analytics person. It is important to understand the end-to-end process. You should focus on the skill set that you driving your statistical modeling skill set. You're bringing data from different sources into one place and so forth. So what I'm suggesting is do all of that, be ready when you go to the market, and also understand which industry you're focusing on. If you're focusing on, for example, retail, then you should understand the retail industry as it is, so that when you go to market and talk to people, then people are, you can explain to them in their language. Does it make sense?
Yeah.
Yep.
So, like,
Yep, go on.
like I worked for a business client, so it was a retail merchandise.
Mm-hmm.
So I worked for quite some time, so I get to understand their business, like how they are pulling out the data, because we used to generate reports for them, and also we need to give them our suggestion, our insight, like what data says to us, because they are like the more of a like analytics person than less of a technical guy. But we were more of a technical and less of analytical. But since we are having hands-on on tools, so we can project it as they give us their requirement.
See,
So
yep, go on.
yeah, yes, sir. Please go ahead.
Yep.
I'm
So that is a challenge that you will definitely find in the market. You will find a lot of technical people, technology people, and not analytics people in the business, in the marketplace as well. Now that is very important, and that's where it is important for you to understand how much of analytics you want to take to the market when you go and talk to someone, and not just showcasing your skill set. That's where I was saying that it is important for you to understand the business domain as well. Does it make sense?
yes, sir. Okay. Thank you, sir.
Thank you, sir.
Any other
So we
question?
have another question from Anushka. Anushka, you can go ahead with your question.
Sure, thank you. Hello, sir. Thank you for this informative session. So, as we have already, as you've already showed us how we can, incorporate data analysis in human resource management with that attrition example. But specifically, human resource management is a domain, is a specification where artificial intelligence has not yet, probed into. So, how can we expect artificial intelligence and data analysis to, to revolutionize the human resource management in the post-COVID world?
So in the
What can we expect?
yeah. So see, I think it is easy. The good point is that as much of psychology is required in human resources is required to solve data problems as well, because you need to understand the psychology of a person when you're talking human resources. When I'm having a chat with you, I need to understand what you're thinking. I need to understand your psychology as well, and that happens from a human resources point of view as well. So I think that is very, very, very easy. The only challenge is that we need to find little projects, little success stories within various aspects of human resources and bring them together so that they can all come together in one place and they can interact and make that. See, an AI project is not a project by itself. You don't have a big AI model. It is collection and orchestration of little projects, so little solutions, little analytic solutions, and that is where it all becomes artificial intelligence, and that is important. So what, as I said, I only showed you one aspect of it. There are other aspects as well that are being taken care of at the moment, but they're not, and you're right, they're not very, very integrated. They're not very well thought through as we go forward. But yeah, it is going to change.
Sure. Thank you, sir.
Did that answer the question?
Yes. Thank you.
Okay.
Thank you, sir. Sir, we have another question from Nikhil Shah.
Hi, Nikhil.
Hello, good evening, sir.
Good evening.
Hello.
Hello, hi. Keep going.
Yeah, sir, actually, previously I have worked in Tata Steel. So there, one of the major challenges that we have faced is that we have a lot of KPI that we monitor, and each KPI is somewhat related to the another. They are very much correlated with each other. So if there is an abnormality in one particular KPI, and it's become very difficult to track it down because we monitor those KPIs in control or trend chart. And the data that we get for these monitoring the KPI, we get it from the SAP HANA. So is there any better way of monitoring those KPI?
Well, I'm not the right person to answer that question, so I don't know. But yeah, I don't know, to be honest. I can't answer that question.
Sir, we had actually asked questions to students while registering, they had few questions.
Yep, keep
So
going.
we go ahead with those questions now.
Yeah, keep going. Anyone wants to ask any question?
If students have any other questions, they can unmute themselves and go ahead. Otherwise, I'll just ask that question in the meantime. So, sir, we had a question saying we know the volume of data is one of the big B's of data. In big data nowadays, every platform is generating millions of data transactions daily. Example, Flipkart has more than 5 lakhs order transactions per day.
Yep.
So do we see any possibility of data recycling in the near future like we have for tangible resources?
Yes, that's a very good point. Data recycling is happening at the moment, and data, more and more data is created, but it is used. The recycling aspect is it is used to refill the future orders or the future interactions. So it is not recycling. Recycling word is not the right word for this. But what you're doing is you're using your past data to actually fill up the future interaction in the transaction with the customers. So I think that is already happening. But recycling per se, well, I'm an analytics person, and I would need as much data as possible. So give me more, and I'll have it for lunch, for dinner, and that's what is important. So I think you need to define what recycling is. Recycling, to use data to solve something, to update some more information, that's happening today.
Okay, sir. Thank you so much. We have another question. Out of every sector, data is most crucial for finance sector for number crunching and analysis to take strategic decisions. How being an MBA student, this can help us or we can leverage this opportunity.
See, it's not only finance, it is everywhere. Data is very important in all the aspects. Now, when you're saying in the finance environment, I've got access to the data. Well, first of all, that is the most sensitive data. Finance data is the most sensitive data. It won't be available, it won't be readily available anywhere. You're not going to access anyone's finance data. So, yes, for even the organizations won't share that information at the very granular level. But yes, you can learn from what is available in the market and understand from that, and answer questions when it comes to your interviews, and learn from that. But I think more and more data is available for interactions with customers, interaction with people, social media, and all of that. But you could always use, now your point was across the financial data. The data that you can actually process before going for an interview is to understand what that organization or what that where you're going for an interview, that organization is actually taking that in, and what is it, what are their, what is their background, so that you can have a better discussion with them. And I think that's the only thing I would advise you at this stage, because this data is sensitive and it's not readily available, and I would not even ask you to actually get access to that data even if it is available, because that is not right.
Okay, sir. So we just go ahead with one last question.
Mhm.
So can you help us, like, since we are learning data science, we are studying. So can you help us to know how the corporate world uses it and what skills do we require to go forward in this field?
I think I clarified that, and that's a question that has been asked to me almost every session I run for women in data science, and you should watch one of those episodes. But what I'll do is I'll try and answer that question very quickly. In fact, what I'll also do is I'll give you my the link to the channel as well, so that you can subscribe to the channel. Where is it? Give me a minute, and I will answer that question now. That's my channel, and okay, here we go. So let me put that here, so that chat in channel member is only available to team members, so I can't chat. So what do I do? I can't even chat. Anyways, so what I'm saying is the skills that is required. So a data scientist, a true data scientist, does not exist. First of all, there are three components of data science. One, collecting data. Second, building statistical models. And third, communication, which is interacting with the business, interacting with the stakeholders. What you could do is you could build your skill set in one of these three areas. The one who writes or collects data, you would require a lot of IT skills to bring data together, to write SQL, to get data there. The second skill set, which is the statistical modeling skills, you would need to get a lot of understanding of statistics. You would need to learn softwares like Python, SAS, R, all the statistical softwares, and understand what each and every model can do for you and how it is working on. So that is where you would be looking at building that. And the third skill, which is very rare in India, is the communication skill, wherein you as an individual would be interacting and explaining to the business what that model actually means. You would need presentation skills, you would need communication skills, you would need understanding of the data, understanding of stats, to simplify and dumbify it, so that when people understand that, people read that, they can actually understand, they can actually take it from there. So that these are the key important areas that you would actually work on one of the three. Now, what people generally do is they try and get all three into one and miserably fail in all three of them. I suggest you create a major and a minor approach. You think that you would want to focus on, say, statistical modeling, and apart from that, you will also focus on collecting data or communication. So take one as your major thing and the others as your minor things that you want to take them together, and that is where you would succeed. So out of the three pillars, where data collection, building models, and interaction or insight generation, I think you could pick one as a major and one as a minor. But these three skills, do not try and get all three all three in one place, because that is not going to work.
Okay, sir. Thank you, sir. We'll keep this in mind.
Mhm. And I've
So,
got, I think, I've got Shalini who's raised her hand.
Yes, sir. I had a question on what skills, what data science and analytics skills should be there for a product manager or a growth engineer role?
Growth engineer role.
Should be, yeah.
Okay, you need to product manager and growth engineer role for a particular analytics product. I think you should have communication skills as your core. You should work on your insights, understanding of insights, understanding of business, understanding of the business domain, understanding of the product, and also how you will showcase it to the customers, clients, or whosoever your stakeholders are. That is a key. You should also have an understanding of statistics, and you should also have a little understanding of data. So you may not be doing core data modeling or statistical modeling, but you need to understand the core behind it. You need to understand how it all works. And if you don't do that, then there will be a challenge. So what I suggest is, please build your communication skills, work on your communication skills, and to the T, write presentations, be very crisp, make sure that your presentations are very structured, bring structure to your discussion, and have a good understanding of stats. That goes without saying.
Thank you, sir. So descriptive statistics, I'm assuming.
Yep.
Am I right?
Yep.
Yeah. Thank you.
Just give me a minute. What I will do is, Shivani, are you there?
Yes, sir.
What I'm doing is I'm sharing my YouTube channel's link, and if you can share it with the entire team who are here so that they can watch. There are lots of sessions that you can watch in your free time and learn from, because there are lots of team members who are leaders who've come on to various shows that I've got. Here it is. I've just shared it with you. Just share it with the audience so that they can also learn as they go, because I get people I've got people from various industries, mostly in India, because I've gone India focused for a while, and they're very senior leaders who would come in and talk about processes, analytics processes. They talk about skill set that are required, and they also talk about success stories. And that show is on Thursdays. So it'll be great if you could, if you want to follow that, then build that there, and follow the channel and press the bell icon so you get alerted.
So we have shared the link to the students.
Okay. Any other question? I still have got time. Don't worry. If you've got questions, I'm more than happy to answer. So I'm assuming that 62 people have understood what I said, so I can ask questions now. Anyone asking questions? No. No, Anshu has raised a question.
Hi sir, Ashu Bhargava this side.
Hi Ashu.
Sir, my question, as you mentioned in the starting of your PPT, that you will be defining the difference between AI, big data, and machine learning. So can you brief on that?
Good point. So you picked something from my slides. Good job. Okay. There are three components of it. Let's start, and I think I tried to explain that. Maybe I didn't get it right, but let's do it now. So what happens is, you've got, so there are three words: artificial intelligence, machine learning, and analytics, right? All are with me? Let's think about this. What is artificial intelligence? Artificial intelligence is mimicking human intelligence. Simple plain English. I'm not talking any gobbledygook here. Simple plain English. Artificial intelligence is mimicking human intelligence. So anyone who can, any process that can mimic what a human would do is artificial intelligence. So what are the components of that? And let's look at human intelligence now. How does human intelligence work? When I'm talking to you, how am I interacting with you? I take in data in three formats. Through vision, through my eyes, I'm ingesting what I'm seeing. I would read from a text, or I would hear something, right? There are three areas which I would actually interact with you. I'm interacting with you in these three areas, right? So I'm looking at you, I will be reading. So these are the three data input sources for me. Artificial intelligence, there are three data input sources: text, vision, and audio. So video, audio, and text. Now when that goes in, what do I do? Now I'm talking humans, right? What do? I will take it and my brain will actually break it down and try and understand. So there is a machine learning model right in my head which is trying to interpret what I'm seeing or what I'm hearing or what I'm reading, and it will try and make sense out of it. Let's switch to artificial intelligence. In an artificial intelligence environment, you will have that particular environment, machine learning, which is now interpreting text, voice, video into something and making sense out of it and making a decision on what to do next. Right? So now when I'm talking to you, my brain in milliseconds, in micro milliseconds, has taken a decision that I need to speak the next word. I need to talk machine learning. I need to talk artificial intelligence. Now, whenever I said that statement, there was a micro millisecond decision that was taken in my mind, and the output came out from my mouth. So that is machine learning. So what machine learning is doing, it is interpreting what is coming in, making some decisions, and then helping that part of that machine to execute the next step. That the whole machine is artificial intelligence, as it is mimicking what a human would do. So you can make it smaller to processes now. When you make it smaller to processes, then each process that ingests something, executes it, takes a smart decision, and returns back something that is a part of artificial intelligence.
Okay.
So now have I clarified what is...
Yeah.
Okay, so artificial intelligence has a part called machine learning. So machine learning is part of artificial intelligence, and predictive analysis or analytics or statistical modeling is part of machine learning. Because most of the people will say that a regression model or a neural networks or you name it, decision tree is machine learning. No, it's not. That is one component of machine learning. A predictive model needs to be recalibrated time and again because the data changes. Because when the data changes, the whole thing changes, the whole model changes. So you need someone like me who will go to recalibrate the model. But when the model starts doing self-modeling and self-recalibration, that is when machine learning comes into play. I've actually created a video which I will be publishing in a couple of weeks, which actually explains various types of statistical modeling models. Whether it is supervised, unsupervised, semi-supervised, I've actually built that all together. So you can watch that video and you will get to learn a bit about that as well. But this is the difference. Never ever go to someone and say that I've built an artificial intelligence model. There is none. There is nothing called artificial intelligence model or artificial intelligence algorithm. There is an algorithm which is in statistical modeling that is part of machine learning, which is part of artificial intelligence. Does that make sense?
Yes, sir.
So don't sell anyone artificial intelligence, because when you do that, they will think that you don't know anything. Though it's a very good word to talk about. I don't talk about that term artificial intelligence because it is not yet there. It's not yet there. For some people it's good to sell, but it doesn't work. Make sense?
Yes, sir. And sir, what about the big data? You have talked about machine learning and artificial intelligence. And the big data is, I think, something different.
Yes. So big data basically is storage of large volumes of data into one place, and it had, in those days when they built it, as velocity, veracity, and variety as the three different components that would define big data. Means, and volume, sorry, four: volume, velocity, variety, and velocity, if I've not repeated that, anyways. And the fourth one, sorry, and the fourth or the fifth one is value, which everyone misses. Value, everyone misses. Everyone talks about volume, variety, veracity, but no one talks about value. So the value is the most important one, but it is collection of large volumes of data. In fact, I'll tell you, I was building a model for someone, and it was a very successful model. That organization was actually making around about $100 million from that model. $100 million from that model. But the amount of data that we used was 3 years weekly data. So when you look at 3 years weekly data, how much would that be?
So 52 into 3.
150, 156 rows, right? And this
Yes, sir.
another gentleman comes to me and says, "Oh, that's a big data problem." Not really. Define big data to me. And they said volume, velocity, variety. And I said, yeah, that's true. So the volume I'm dealing with here is 156 rows. Is it big data? No. But because it is valuable to someone, they would want to make it a big data exercise.
Okay, sir.
Good stuff.
So the language we use to build the models is, I think, same for all. We can use the same language for all three of them.
Yep.
Like Python.
Yeah, you can use Python, yes.
Okay, sir.
Yep.
Thank you, sir.
Thank you. Anyone else has a question? Or are we exhausted?
So I think we're done with the questions.
Okay. Good stuff.
Thank you so much, sir, for such an insightful session. It is our privilege to hear from you. On behalf of Goa Institute of Management and Parigyan, I would like to thank you again for taking out time from your busy schedule to address the future leaders out here. Also, a special thanks to all the students for being a part of this event and for sharing ideas and discussing ways to harness the full potential of data science. Thank you so much.
Thank you.
Thank you so much, sir.